This video is about the Doppler effect and it comes up in P1 part 2. Okay, now the Doppler effect is something that people find quite a hard concept to get their head around, but it is predominantly quite a simple process. This is the definition for it. So the Sheldon Cooper definition of it, if you've ever seen the Big Bang Theory episode, it is the apparent change in the frequency of a wave caused by the relative motion between the source of the wave and the observer. Now it sounds really complicated, but if you break it down, the apparent change. So apparent means, does it actually really happen? When someone says to you, apparently she said this about me, have you got proof? No. So it doesn't necessarily have to happen. And then when it says in the frequency, well, if you know anything about sound waves, you know that the frequency has got everything to do with the pitch. So it's an apparent change in the pitch of a wave caused by the relative motion. Now, relative motion means that something moves compared to something else, so something's moving between the source of the wave, so the thing making the sound, that's the source of a wave, thing making a sound is a wave source, and the observer, the person listening to this sound. So it's the apparent change in the frequency, so the pitch changes, of a wave caused by the motion between the thing making the sound and the person listening to the sound. That's all it means. So you have here a car and it's playing some banging tunes, and we all know that sound is longitudinal, but if you were to put it through an oscilloscope, you would visualize it like this. So no matter where you stand, here or here, you would hear the same pitch, because imagine it's making a constant pitch. The volume would eventually get a bit quieter the further you get away, but no matter where you stand, you would hear the same pitch. So same pitch, no matter where you stand, for a stationary object making the sound, wave source. As soon as that wave source starts to move, what happens is these waves that are being produced, these longitudinal waves, become compressed. So that decreases our wavelength, which means that it is a higher frequency, therefore a higher pitch. So something coming towards you really quickly, then it's going to compress these waves. So coming towards you, you're going to hear a much higher pitch. I always think about it, if you move your hand quicker and quicker, you can feel the air compressing against you. So the quicker you're moving, the more you're going to compress these waves. So coming towards you, you would hear a high pitch. As soon as it's gone past you, these waves are now spread out. So you're going to have a longer wavelength, therefore a lower frequency, so a lower pitch. And you might hear, oh. The thing you need to remember though is the person playing these banging tunes is going to hear the same pitch throughout, because they are not moving relative to themselves. It's only the person who is the observer that will notice the change. So this wave source doesn't actually change its frequency, it only appears to change, caused by the motion of this between the observer. Last year they related it to radar guns, okay? So the way, I'm not talking about speed cameras, that the ones that take pictures, that's done by pictures. The ones when you get the policeman standing at the side of the road trying to get you with a speed gun, is the fact that it emits radio waves and they reflect off of the car. If the car's moving towards the camera, it then reflects these waves back. If they're more bunched up when they're reflected back, it must mean the car is moving faster, and that's how they can then do you for speeding, okay? An exam question might be something like this. So the diagram shows a teacher with a loudspeaker and they're using it to demonstrate the Doppler effect. The loudspeaker produces a constant note, that's really important, and is swung around in circles. So you've got the teacher here, I'd never do this, I'd end up hitting someone by accident, and then it's going towards the students here, and then it's moving away from the students. So as it comes towards the students, you'd hear a higher pitch. As it then goes away, you would hear a lower pitch. So then it says, what is the Doppler effect for 2 marks? So the Doppler effect, I would say, is the apparent change, can't hold this as well, in the frequency of a wave caused by the relative motion between the source of a wave and the, I'm not even on it, the observer. There we go. And if you have a look at the mark scheme here, it says change is observed in the wavelength or frequency when the source moves closer, when the waves or observer move relative to each other. Okay, so it isn't as difficult as what you first think.